All right, algebra team, we are here today to talk about exponent rules. If you don't have a piece of paper and a pencil, pause the video and go get some. Okay, if you are here, that is because you are ready with pencil, paper, and an open mind. We are going to talk about some exponent rules, and today I'm going to prove some of the things to you that seemed hopefully sort of intuitive. Let's review. If I have something called like 5 to the 4th power, this right here is the base of the exponent. This is the exponent or the power. Sometimes we refer to the entire thing as the exponent. Now, what this means is that we have 4 5s being multiplied together. Remember that exponentiation is a shortcut for multiplication. So we can say 5 to the 4th, that's the same as 5 times 5 times 5 times 5. Now, I happen to know that that multiplies to make 625, but for the most part, we're not going to worry about that part, the multiplication. We really care about this right here. So, let's take a look at what happens when we multiply powers with like bases. Yes, you have to write this down. One of our goals today is to be able to multiply powers with like bases. So let's say we had something like 3 to the 4th power times 3 to the 7th power. Now here's what I want you to notice. These are both powers and their bases are the same. The bases are 3. Now we could think of this as a multiplication problem with a little multiplication dot. We could think of it as a multiplication problem with parentheses, but essentially what we're going to get is 3 to the 4th, 3 times 3 times 3 times 3, 4 3s, times 3 to the 7th. Move my paper over to fit all 7 3s. 1, 2, 3, 4, 5, 6, 7. Now, we're not going to worry about multiplying this out because this is going to be a very big number. Instead, we're going to use exponentiation as a shortcut for this repeated multiplication. So how many 3s do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 3s. 3 to the 11th power. Remember that in mathematics, we are trying to notice patterns, describe patterns, and generalize patterns. So I wonder if you're noticing a pattern here. Let's look at another example to see what you notice. So let's say we have, let's use a variable, x. X to the 5th power times x to the 2nd power. Well, that's going to be x times x times x times x times x, 5 x's, 1, 2, 3, 4, 5. And we're going to multiply that by 2 x's, 1, 2. How many x's do I have? 1, 2, 3, 4, 5, 6, 7. So that is x to the 7th power. Now, I'm curious if you're noticing a pattern. I'm curious if you've noticed that 4 plus 7 equals 11, and 5 plus 2 equals 7. So that when we multiply powers with like bases, we've noticed the pattern. Maybe we would describe the pattern and say, when you multiply powers with like bases, you add the exponents. Or we could generalize this and use any number. So any number to the m power, just any power, times any number to the nth power. Notice that the bases are the same, like bases. You're going to add the exponents. So you'll get a to the m plus n. A to the n, m times a to the n is equal to a to the m plus n.